So hello everyone. Today I will teach you how to do supervised classification using Dzetsaka plugin in Quantum GIS. So today we will learn how to create land use land cover map of Inazaki City in Ibaraki Prefecture, Japan. Before that, we need to prepare the dataset first. So you can go to this address, okay, and then you may scroll down, okay. And then you can download the nationwide, and then you can click this icon, okay. And then it will come with zip file, so you need to unzip the file first. So you go to your browser, your working folder, and unzip the file. In this case, I unzip the file in my scuba folders here. So this is the file of unzip file. So if you go to this folder, you can see there are so many datasets about the prefecture and city's boundary within national in Japan. Okay, then you can go to QGIS, then open your set file here. This is the national scale set file. Then you can zoom into around Tsukuba or Ibaraki, and then you can select the Inashiki prefecture here like this. Okay, it's been selected, and then you can zoom to selected location. You can also change the projection. In this case, I would like to use UTM zone 54 north, and then click OK. Okay, then from this file, we need to export the selected boundary to GeoJSON. So you can go to layer and then save as layer, save only selected features and select GeoJSON here. Put the file name, select the folders. Here I already have Inazaki GeoJSON here. So I will cancel, and then you can just click OK. Then the next step is you go to you go to the next browser here, Copernicus Dataspace browser. Okay, then you click on this icon and then upload your study area and drop the dataset. Click here and select Inazaki GeoJSON and click open like this. Okay, now it's already open. Go to search, select Sentinel-2, MSI level 1, C, and the cloud cover less than 10%. Okay, then you can select the time ranks. In this case, I will select January 1st into November 29, and then you can just click search. Then just wait for a couple seconds. Okay, now this is the result. So I want to download the data around May, for example, this one. Okay, it is acquired on 11 May 2024. You just click visualize here, and then you can select false color or true color, or maybe highlight optimized natural color like this. Okay, I will go back to false color, and then I want to download the raw datasets. Click on this icon to download the image. Go to analytical, select TIFF 8-bit, resolution is high, coordinate system, we will make it consistent with our project, UTM 54 North, and we uncheck the false color because we need all raw datasets here. Okay, check all raw data and then click download. It will be downloaded again in zip file, so you need to unzip the file. I already did. And then I go back to my folder, and this is my browser image. This is the download file, and this is the unzip extracted folder. So you have raw data from band 1 to band 12 raw data TIFF. Okay. Okay. Then go to QGIS, and then you can select all the band, just click hold and drag into your QGIS like this. Okay, so you have band 1 to band 12. Okay, we don't need this boundary. You can remove if you want. You remove the layer. Okay, now the data already clipped based on the Inasiki city's boundary. Okay, next step is we want to create a false color composite RGB. You go to raster, miscellaneous, and build field to a raster. Don't forget to check, place each input file into a separate band. Resolution is highest. And here, you may select all the band like this. Or if you want to make it faster, the classification processing, in this case, we just want to select band 6, band 4, then band 2. Why? Because we want to create false colors RGB composite to highlight the vegetation, easier for us to distinguish the Earth features on the image. Okay, can go back. Okay, and then if you want to save the file, you can select here, scroll down and select save to file. You can put in a CKey RGB composite color or so on. In this case, I don't want to save. I just want to create a temporary layer. Okay, go back here and then select the highest. Select band 6, 4, and 2 like this. Place each band input file into a separate and then click run. And you have a virtual RGB composite like this. At first, the arrangement is band 1, 2, and 3. You can double click to change the multi-band arrangement. Select band 3, 2, and 1. Contrast enhancement, you can select stretch to minimum, maximum. And for the value setting, you select mean standard deviation. You can click apply. And okay, so you can see here, now you can easily distinguish the Earth features. Okay, land use, land cover. Here we can see some agricultures, built up area, solar panel, vegetation, agricultural area, bare land, and so on. Okay. Next, if you want to add some base map, you can go to Quick Map Services plugin icon and select R3, for example, and select National Geographic like this. Okay. Next step, we want to do supervised classification using the Dzetsaka plugin. So you need to go to plugin, manage and install plugin. Just wait for a couple of seconds, and then in the old plugin, you just type Dzetsaka here I already have. Okay. In your case, you need to install the plugin first. Then you need to make some setting here. If you click on this icon, you can create the certifications algorithm, the classifier. At first, you can only use this one, Gaussian mixture model. If you want to use random forest, for example, you need to install some dependency first. Okay. In this case, you may go to these websites, this one, and then you can scroll down and follow the guidance here how to install Skitchit Learn here. Okay, using Linux or in Windows, you can go to OS GeoCell and then you can just type and execute this code. Okay, it's quite convenient, quite simple. Okay, if finished, you can go back to your QGIS and you can create the region of interest. In this plugin, it is quite simple and quite easy to do the classification because in classification, we just need a raster and a shape file. And this shape file needs and must contain a classification number. So you need to write down your classification number. Okay, otherwise it will not work like this. So if you want to create classification like this, so just remember to write down the class. For example, in this case, I prepare the class here. 1 is urban, 2 for vegetation, 3 for agriculture, 4 for land, 5 is water, 6 solar panel, and 7 is not defined. Okay, nothing. Okay, we go back to QGIS. Then to create a layer for region of interest, you go to layer, create layer, and you set file layer. Okay, and then here you may create a new one, for example, class, and it should be integer. Okay, and then you can add like this. Okay, if you want to delete this one, you can remove, and then you can add for land use and cover, for example, like this, and this should be text. Maybe you can put the length 30 and you can add here. So if you create the region of interest, you can add the ID in the class and then the type. For example, ID 1, class 1, the land use and cover is urban. Okay, I already have, so I will cancel. I just want to load my layer. Add vector layer. I have here, so this is my region of interest set file, this one. Okay, sorry, I go back here. Layer, add vector layer, and just click add. So I have this one. If you want to create again, for example, this location is for you can check on the table. This is for not defined data because there's no data. Okay, you can click on this icon, toggle editing, and then you can create new polygon here. Just click, and to close the polygon, just right click and put the ID 7 plus is none, like this. Okay, you can click OK. The same way if you want to add, for example, some vegetation location, if you are not sure, you can add satellite image from Google like this, and then you can check. You may uncheck everything, sorry, like this, and then just check the satellite image and then your region of interest boundary here. Okay, so it is clear this is urban or bit of area. Okay, so you check again your virtual layer and then you can create the new polygon here. Okay, do the same thing. In this case, I create I create 3 for each class: urban 3 polygon, vegetation 3 polygon, agriculture 3 polygon, and so on for data training. Okay, and when you create the region of interest here, you can go back to layer, create layer, use a file layer. Make sure here your projection must be consistent with the raster data. It should be UTM zone 54 north. Okay, make sure. So to make it easier, I just double click my region and interest, and then I go to categorize. I want to select the ID and then classify the ID. You can change the region here to make it easier for you. This is urban. Number 2 is vegetation, agriculture, and land. Number 6 is water. Sorry, number 5 water. Number 6 is solar panel. Number 7 is none. No data set. Okay, can apply. Or maybe if you want to add the label to make it easier for you, single label, and the label is class, and then you can draw the buffer, add the mask, or maybe you can add the shadow like this. It's okay, it's fine. Or maybe if you want to set this one, okay, okay. Can zoom to layer, so you have none here, you have agriculture, vegetation, badland here, urban area, solar panel location, and so on. Okay, so next step, if we want to perform the classification, you may check again your setting. Okay, in this case, I will select random forest for the classifier. Make sure this is the raster input is virtual layer with 642 band here, and make sure the region of interest same, consistent, the projection and the ID is, and then you just click perform the classification. Okay. It takes times. The classification process is depend on your computer performance and your computer specifications. If you have a good or high computer specification, maybe it will take some less than 5 minutes. But if you have some low computer specification, maybe it will take hours to finish the classification process. Okay, it's finished. So you have at first the result will show you in white and black color. So we remove this one, we only need one. Okay, the next step is what you can do is you can make some different symbology. You can go to symbology and then you can use palette and then you can classify like this. You can just click apply and check the result like this. Okay, so the result is quite good. The next step is we want to convert the raster classification into vector. So you can close this one and you may go to raster, extraction, conversion and polygonize raster to vector. Okay, this is the input layer and this name and the vectorize. If you want to save the vector, you can select save to file. In this case, I just want to run and execute the program. No worries with this warning, there's no problem. Okay, we finish and we have a vector land use land cover datasets. Now you can check on the attribute table here. We have so many ID, so many class. So we need to dissolve this class to calculate the array of each land use land cover. Okay, you can close and then you go to vector, preprocessing and dissolve. Select vectorize and click run. Okay, we just put it into a temporary layer. Okay, it's finished. Then this is the dissolved data. You can click and then select the symbology. You can select categorize and select the number. Why only one? I think I made mistake here. You can go back to dissolve, select and check Vectorize again. We want to use digital number, right? To dissolve based on the digital number. Okay. We go back to factor again, geoprocessing and dissolve. Vectorize. Oh, here I forgot. You need to select this dissolve file here. We select digital number. Okay, I'm sorry. And then you can click run. Okay, that's why I only click run without save into the folder. If some mistake, you made some mistake like this, you can just go back, you can delete the result, and then you can redo again the process. It is quite convenient. Okay, so this is the best example why I only choose the temporary layer, because sometimes in the process we made mistake like this. Okay, finish. So this is the result of the dissolve. We go back again to the attribute table. Now we have this class based on the numbers. Okay, so now if you want to add a new field like this, sorry, we just start editing. And then if you want to delete FID, you can delete the FID column because we don't need this one. And we need to add a new column called area. It is in hectares. And then we put dollar symbol here, select area, multiply by 1 E4 like this. So this in hectare. If you want to put in kilometer square, just select 6 here. Okay, just type 6. Okay, in this case, I go back to hectare and then click OK. Now we have an area of each land use land cover. Okay, then if you want to add another column, for example, percentage, then you can put the field here, the area. Okay, area divided by sum of area like this, and then multiply by 100. So you have percentage here. Okay, now we have percentage. You can see here class number 1, urban area 8%, vegetation 70%, 17%. Agriculture is dominate 21%. Bare land is quite small, also with the solar panel here, but water is quite big. Okay, if you want to add another column here, for example, you want to put the label of the each land use land cover, you can put select string. The name is class. This is the land use land cover class, and then the type here just 30 for the length. Okay, click OK. Class number 1 is urban. Number 2 is vegetation, agriculture, wetland, water, solar panel, and this is none. Okay, then you can save and stop editing. Then you can modify symbology to categorize, maybe for make it beautiful. Stroke color, we select transparent in the symbology, go to categorize, and then you select class, you can classify based on the class. And then for agriculture here, you can select, for example, dark green or maybe light green for agriculture. Light green, Berlin, we can select orangey. Solar panel, we can select gray. Urban area, we can select red for urban area. Vegetations, we select dark green. And water, of course, we select intuitive color, blue. Okay, like this. Okay, you can click apply. And this is the result. Okay. Then we can uncheck the others. Okay, and none. Where is none? Other value. Other value, you may select maybe this one. But if you want to delete, also no problem. Okay, you can select okay first. Then this is still temporary, so you can save your classification result, classification in a key. Classification. Okay. Save. Okay. Just wait. Okay. If you want to open your classification file, you can select click here, click, and then the folder will open. In a C classification, if you want to open in QGIS, just click, select, and drag. Yeah, so this is the dissolve file. Just wait for your classification layer will be open. Okay. Okay, we go back to the solve layer. We can copy style, and for Inasiki, you can pass the style. Where is it? Okay, just wait. Okay, this finish. And then if you want to delete the none layer here, you can say here we still have none layer. Go back to editing and select this layer. Or maybe just open the attribute table. Okay, so they select it like this. Then you can delete. Okay, you don't need this one. Okay, so it's better. Don't forget to save your project. Then you can go back to attribute table and check everything is correct. So we have digit number, we have the area in hectare, we have percentage, and we have class. That's all for land use land cover classification using supervised methods and Dzetsaka classification plugin in Quantum.js. Thank you.